in this example, he's asking for energy stored in the inductor and energy stored in the capacitor. Okay, so all I care for finding the current in the inductor and voltage across the capacitor. So you can do the mesh analysis or nodal analysis. First step, we know this is a DC circuit. So it's a DC circuit. We know that in DC, inductor act like a short, capacitor act like a open. Okay, so that's going to be open. That's going to be short. Okay, so this is how the circuit is going to be look like. That's 3 ohm, 5 ohm, 10 ohm, and 20 ohm. 10 volt here, 20 volt there. So my goal is, as long as if I find the voltage at this point, do we know the voltage at this point? I do, because if I ground this, the voltage here must be 10 volt. Okay, so I'm going to call this as Vx. Say at Vx, apply KCL. Okay, if I apply KCL, I'm going to take this current as coming in, I1, I2, and I3. So I1 equal to I2 plus I3. So here, what is I1? I1 is nothing but 20 minus Vx over 3 equal to I2 is nothing but Vx minus 10 over 10 plus I3 is Vx minus 10 over 20. I'm going to multiply this with 60 on both sides to eliminate the denominator. So 20 times 20, that is 400 minus 20 Vx equal to 6 Vx minus 60 plus 3 Vx minus 30. Okay, so 20, if I take it to the other side, that's going to be 29 Vx equal to, I need to move these two terms to the other side, which is 490. What is Vx in this case? Vx equal to 490 divided by 29. I have 16.89 volt. Okay, so once I find the Vx is the voltage at this point, 16.89 volt. Can we find the voltage across capacitor? So energy stored in the capacitor equal to half CV square. I have half, C value is 0.1 millifarad. So 0.1 times 10 to the power of minus 3, V square is 16.89 whole square. Okay, that will give us the energy stored in the capacitor. I have this value as 0.014 joules. And energy stored in the inductor is half Li square. What is the current passing through this inductor? I can label this as I2. I mean, I labeled it as I2. I2 equal to Vx minus 10 over 10. That will give you I2, which is 16.89 minus 10 over 10, which is 6.89 over 10, which is 0.689 ampere. So I know the current in the inductor, half L value is 2 Henry, 2 times I square is 0.689 whole square. Okay, I end up this value as 0.475 joules. That is the energy stored in the inductor.